Okay, this one comes from Fivio Foreign. It looks like a trig question again that talks about solutions of triangles, 2D and 3D triangles. This one is three-dimensional, okay? No difficulties when you're dealing with these questions. Before I even answer it, I want to encourage you to always keep this in mind. The questions will change. The concept will not change. The concept remains the same. The duty of the examiner is just to find a weird diagram they can use to make your life difficult, all right? But if you understand the concept, you will never go wrong. When you are here, in my mind, the first thing that always comes to my mind is, for me to solve these things, obviously I know sine rule, cosine rule, area rule are going to play a role, okay? And your sine, cos, and tan ratios, sine, opposite, over, your SOHCAHTOA basically is going to play a role. But above all, before we can even think of those, my brain already knows that I need a triangle that has a minimum of 3 things for me to do anything on it. If I have that, then I can be able to solve whatever they're looking for. So that is always in my mind. I want a triangle that has a minimum of 3 things, and then if I've got that, then I can be able to figure out what is going on. Right. So let's go to this one. It reads as follows. It says, in the figure below, KM is a vertical post set in the center of 2 circles which lie on the same horizontal plane. Angle MKN is equal to angle MLK is equal to X. The radius of the inner circle, ML, is R units, and the radius of the outer circle, MN, is equal to 2R units. Okay? Now, 7.1 is asking us to calculate the value of X. All right. Now, let's identify the triangles that are going on here. If you can see them, you can do something about them. I'm going to highlight the triangles where there's X, and then we're going to attempt to find the value of X. All right. So let's see what is going on here. The first triangle that I see is the triangle KML. This is a triangle that you would get in the smaller circle. The angle here is this X degrees that the examiner is interested in, okay? At the top, we've got K. At the bottom, we have M. Now, that triangle does not have enough information. As much as it does have the X we're looking for, when I isolate it, it's going to look like this, beautiful people. It has L here, it has M here, it has a 90 degree because the vertical will always be perpendicular to the horizontal. I've got K here, okay? And I've got a length of R units, small letter R. And I have X degrees here. So you can see that we actually even have 3 things. We've got X degrees, we've got R, we even have 90 degrees here. We just want to know the value of X. The second triangle that I see in this drawing is triangle KMN, the one that goes to the outside circle, okay, with an angle of X degrees here. So what I'm going to simply do is try to isolate it as well so that you guys can see what is going on. Let's put it as the green triangle, okay? The green triangle has X here at the top. The green triangle has got a radius of 2R, okay? It has K at the top, it has got M here at the bottom, and there's N here. Once more, we are interested in that X. If you look at it, you will agree with me that it also has 3 things on it. There's 2R on it, there's X degrees, and there's 90 degrees. So we can actually do a couple of very exciting things about it. Okay, now since we want to find the value of X, and X appears in 2 different places, let's see if we can set up an equation that can relate the 2 triangles. The beauty about them is they've got a common side. The side KM is appearing in both those 2 triangles. So I feel like if I can set up 2 equations that include KM and X, I'll be able to find a solution. I treat it like I'm looking for some simultaneous kind of like setup. Excuse me for that. Right. So what trig ratio can help me to relate the side KM and the side small r? Okay. That's opposite, that's adjacent. The ratio that will help you marry the opposite and the adjacent is tangent from SOHCAHTOA. So which means the tan of X degrees on the white triangle equals the opposite side, which is KM, divided by the adjacent side, which is small r. From this, we can then say KM is just R multiplied by the tan of X degrees. Now we're going to go to the green triangle. In that triangle again, you're looking at the opposite side. So you again want to marry the opposite side with the adjacent side, opposite and adjacent. Once more, tan will play a role in this. What are we going to say? Well, we'll just say the tan of X degrees is opposite, which is 2R, over adjacent, which is KM. I want to make km the subject here, which means by cross multiplication, km is going to come out as 2r divided by the tan of x degrees. So they're both equal to km, right? The right and the left, okay. I can then equate them because both these things are equal to km, which means we can now say r tan of x degrees equals to 2r divided by tan of x degrees. From here, simplify by just cross multiplication or whatever it is that you may do here, depending on how fresh you are mathematically speaking. We'll cross multiply. I'm getting r tan squared x, okay, equals to 2r. And then divide both sides by r. You're ending up with tan squared x equals to 2, because r is going to get cancelled out when you divide both sides by it. And then we're looking for tan, not tan squared. That means we need to take the square root here. We also need to take the square root. You could put it as plus minus, but it doesn't make sense in this context because the angle cannot be negative. It has to be a positive value since it is in a diagram, which is a triangle, okay? So the tan x is the square root of 2. So x is simply going to be arctan square root of 2. Go to your calculator, and then you just ask it, what is shift tan, open bracket, square root of 2, right? And then you close the bracket. If you press the equality sign, I'm getting 54.74 degrees. 54.74 degrees becomes the solution to the value of x here. If they wanted km, you can obviously go back and substitute your angle of 54.74 degrees because you know now what the value of x is. The next question on this very awesome question that comes from trigonometry. You guys are bombarding us with 3 questions today. They say if r is 5 meters, okay, that's small r. If small r is 5 meters and LMN is 110 degrees and you're also told to work out the length of LN, what would you do in that case, okay? I can see all the things they're talking about, they lie in the green triangle. Let me just draw that green triangle there. What are we interested in? Let's just isolate that triangle so that you guys can see it nicely. So it looks exactly like this. So you've got this triangle, there's L here, there's N. That's what the examiner wants. They're telling you that this angle is 110 degrees. They're telling you that this, which is R, is actually supposed to be 5. And then the other side, which is supposed to be 2R, will obviously be 2R, which is 2 times 5. So you've got 10 there. And this is where M is. We are interested in figuring out the length of LN. Okay? So let's see how will that pan out. I don't know what's happening with my webcam. Okay, come back. There we go. All right, so what I'm going to do here, what I'm going to do now is just to figure out the unknown length, which is small n. It's obviously going to come from the cosine rule. So LM squared is, remember the following, the cosine rule works with 2 sides and the included angle. So if you've got 2 sides and the included angle, it will help you to figure out the third side opposite the angle that you're dealing with. Right, so I'm looking for LM. That means LM is going to be one side squared plus the other side squared minus 2 times 5 and 10 cos of 110 degrees. So then you just press everything in your calculator. The answer should come out easy because you're just looking at numbers everywhere. There's no funny math that needs to go down there. So there's 5 squared. We're adding that with 10, okay, squared. And then we have to subtract 2 times 5. And then we're going to have to multiply it by 10, okay, 2, 5, 10 cos of 110, 110. And then what do you get here? You're getting 159.20. But remember, that is LM squared. So you need to take the square root of alphabet answer. Whatever you find the square root of that, which is 12.62. That's my final answer here. 12.62 will be the length of LN, not LM, because we know what LN is. We're looking for LN. The unknown side is LN. That's basically what the solution to LN is going to be.